slightly lengthy. We will understand it in parts. Let me read it for you. It is, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines it produced indefinitely meet on that side on which the sum of the angles is less than two right angles. Now let's take it word by word. It says, if a straight line falling on two straight lines, look at this part first, a straight line falling on two straight lines. Look at this figure now. Here we have this line. Suppose if I name them, this line L, this is M, and this is N. This line N falls on the other two straight lines L and M. It is similar to the case of a transversal. This line N is transversal for these two lines. So a straight line falling on two straight lines makes the interior angles on the same side of it. Now look at the interior angles formed here. Angle 1 and angle 2 on left side of the transversal, and angle 3 and angle 4 on the right hand side of the transversal. So next part is the interior angles on the same side of it taken together. Taken together means you have to take their sum. So what we have to focus on? Sum of angle 1 and angle 2 and sum of angle 3 and angle 4. The interior angles on the same side of it taken together less than two right angles. Now we have to see sum of which two interior angles on the same side of the transversal is less than two right angles, that is less than 180 degree. Either this or this, less than 180 degree. Then if the two straight lines, if produced indefinitely, if we produce these two straight lines indefinitely on either side of the transversal, then they meet on that side on which the sum of the angles is less than two right angles. If we measure these sums, sum of these angle 1 and angle 2 and angle 3 and angle 4, we will find sum of angle 1 and angle 2 is less than 180, whereas sum of angle 3 and 4 will be greater than 180 degree. So this postulate says that if we produce these two lines indefinitely, then they will meet on the side where the sum of the interior angles is 180 degree, less than 180 degree. So sum of interior angles is less than 180 degree for angle 1 and angle 2. So if we produce them indefinitely, further these two lines will meet on the left hand side of this transversal, because the sum of the interior angles 1 and 2 is less than 180 degree on the left hand side, whereas on the right hand side sum of interior angles is more than 180 degree. So these two lines will never meet if produced indefinitely on the right hand side. Once again I am reading this statement. If a straight line falling on two straight lines, this straight line N falling on two straight lines L and M, makes the interior angles on the same side of it taken together, interior angles on the same side of taken together, angle 1 and angle 2 and angle 3 and angle 4. Now where the sum is less than two right angles, angle 1 and angle 2 is less than 180 degree or two right angles. So if the two straight lines produced indefinitely, they meet on the side on which the sum of angles is less than two right angles. So these two lines will meet on that side where the sum of the interior angles is less than 180 degree. Now this postulate indirectly also implies the existence of parallel lines. It does not talk about the case where the sum of the interior angles will be 180 degree. In that case, if the sum of the interior angles taken together is equal to 180 degree, in that case the lines will be parallel.